Good afternoon, guys. Hello, guys. Good afternoon.
Good afternoon, sir.
Good afternoon. So let us wait for our friends for 2 minutes, and then we are going to start the session. So should we start? Yes. Hello.
Yes, sir.
Okay. So let us start this topic. Okay. So actually, it is also the part of your lab which I wanted to cover in your lab, but let us cover it in theory, and different lab work we will complete in next lab session. We have seen ICR method of velocity analysis. We have also solved two problems on that. Now let us see another method of velocity analysis, which is known as relative velocity method. Okay, it is again a very simple graphical method. Okay, just you have to understand the notations of the vectors, like how to represent a vector. Okay, so again we will revise different types of velocities. As you know, there are two types: absolute velocity and relative velocity. What is absolute velocity? That if you measure the velocity of any moving object with respect to a fixed reference, is called as absolute velocity. Okay, for example, suppose a car is moving. Okay, and suppose a tree is here, some sort of tree. I'm not good at drawing. So this tree is standing on the ground, and this car is moving like this with some velocity. Suppose you want to measure what is the velocity of this car. So what you will do, you will choose some reference to measure its distance, okay, in the given time. For example, I will have this reference, this tree which is standing on the ground, right? Okay, so you will note down that at particular moment it is the position of car, that is nothing but S1, okay, as measured from the tree, as measured from the fixed reference tree, okay, and say after certain time, as time passes, the car has moved to a new position, okay. So at this position, say this distance is S1, okay, and in position 2 you will again measure the distance of the car, but from the reference, your reference is fixed, that is tree. So say it is nothing but your S2, this distance is S2, and the time which is elapsed between these two position S1 and S2, these two position, say it is T, that is small t. So how you will measure the velocity then? Velocity will be equal to, velocity will be equal to, what is the new position S2, okay, minus what was its initial position with respect to a fixed reference upon time. So this velocity uh, for which calculation I chose a fixed reference is called as absolute velocity. Okay, and what is relative velocity? Relative velocity is what? That this velocity you measure with respect to a moving reference. Okay, for example, say it is a car and one bike person is also there. Okay, so say this is the bike, this is the wheels. Okay, a bike is also moving with some velocity. Okay, so now you will say that this is my reference, this bike is my reference. So how you will measure the position of the car? You will measure the position of the car with respect to the bike. Okay, so initially say it has distance between car and bike equal to x1. Okay, suppose after some time car will move to the position S2, so bike will also move in this direction. Okay, and say the bike has moved to the new position somewhere here. Okay, again you consider it as the linear, that you assume that the bike is moving in linear direction. Okay, just as there is no space, I have drawn it here. So this is the bike. When car is at position S2, bike is here. It has also moved because it is also in motion. So at that time you will see what is the distance of car from the moving bike. That is nothing but your x2. Okay. And when you measure the velocity of car with respect to the moving bike, you will find out the velocity as relative velocity. Relative velocity, which will be given by what is the distance between car and bike at position 2, and what was the distance between car and bike at position 1 upon time is same. Time is same, t. Okay, so this will be known as relative velocity. Okay, it is the relative velocity of the car with respect to the moving bike. Are you getting the concept of absolute velocity and relative velocity?
Yes, sir.
Okay, so suppose if in problem if you are asked that find the distance of car from the tree after some time, then the velocity which you have to consider is the absolute velocity. Suppose in the problem if you are asked that find out what will be the distance between moving bike and moving car after some time. So for such calculations you will take the help of relative velocity. What is the relative velocity of the car with respect to bike? Then you can figure out what is the distance between a car and moving bike. So I hope this will clear uh, you are thinking about absolute and relative velocity. Okay, so let us move to the next slide. Now it is very important. Okay, everyone should concentrate on it. That is how will you represent a velocity vector on graph on paper. Okay, because it is also a graphical method of finding the velocity in mechanism. So as we are dealing with velocity, you remember that velocity is a vector quantity, not a scalar quantity. A vector quantity has both magnitude as well as direction. So if you say that velocity of a person is say 5 meter per second, okay, so another person is also interested in direction, that in which direction he is moving, south, north, west, east, that is also important. Okay, so how to then represent if a velocity has magnitude as well as direction? Okay, suppose a point is there, point A. Okay, this point is moving, this point is moving with velocity say 5 meter per second, 5 meter per second. Okay, now I have to represent the velocity of point A on paper. Okay, so this arrow is showing you the direction in which direction it is moving. Okay, so with the help of direction you can draw a line in particular direction. For example, as point A is moving in horizontal direction, so I can represent velocity with the help of a line, okay, whose orientation is horizontal, because the point A is moving in horizontal direction. Again, in order to be more specific, what is the direction of arrow of point A, whether it is moving in right direction or left direction?
Right.
Right direction. Okay, so I will show the arrow like this, the direction in which point A is moving. This arrow you can place anywhere. You can place in the middle of this line, as well as you can place it here also at the end point like this. No problem. Okay. Now you have decided the orientation like horizontal, vertical or inclined depending on the direction of velocity. Okay. Now what about the length? What should be the length of this line? Okay. So length of this vector should represent what? It should represent the magnitude. Okay. Looking at the length of vector, one can say that velocity is more or velocity is less as compared to other velocities. A point which is having higher velocity, its vector will have more length. Okay, so more your length is the representation of the magnitude. So suppose 5 its velocity is 5 meter per second. Okay, now I have to keep the length of this vector as 5 meter. Okay, I have to select some suitable scale for it. Okay, now you see if I will keep 5 meter length, then the length will be very long. Line will be very long and it will not accommodate in given paper size. So I will select some scale for it. Okay, suppose I select that I will represent 1 meter per second by the length of 1 centimeter. Okay, say 1 meter per second, 1 meter per second is equal to 1 centimeter. Okay, then if your velocity is 5 meter per second, the length of the vector will be 5 centimeter, right? Correct?
So
Okay, so I will draw this line first in horizontal direction and I will choose the length as 5 centimeter because I have selected here that 1 meter per second velocity will be represented by 1 centimeter length. Okay, so I will draw this line equal to 5 centimeter. 5 centimeter. Got it? So you can see I have drawn the vector for velocity of point A. I have rightly represented the velocity of point A by a vector. I have drawn a vector. Okay. The next important thing is its notation. Now we have to label it. We have to give some name to this vector. Okay. Okay. So suppose let us assume that we have measured the velocity of point A with respect to some fixed reference. Okay, with respect to some fixed reference. So now you remember that whatever is the direction of this arrow, it shows the velocity of that point. Okay, suppose uh, there is one point, say point O. It is the point. It is point O, and this point is fixed. Okay, so I am measuring the velocity of point A with respect to point O, which is a fixed point. Okay, so the point with respect to which you are measuring the velocity is written first. That is, starting point of the vector is point O and end point of the vector is point A. Okay, so what is it? Which velocity it is? So suppose this, you have to see this arrow. Arrow is towards A. So you will say that this vector is for velocity of point A, because this, it is pointing to the point A. So I will call this vector as, it is nothing but velocity of point A because of the direction of arrow. Arrow is towards point A. So it is the velocity of point A. Okay, and with respect to which point? So the initial point of the vector shows that reference point. Okay, so velocity of point A with respect to O. Are you getting this label, this notation? Very important.
Yes, sir.
Okay, suppose now write I will write a velocity. You have to tell me what is it, means velocity of something with respect to something, you have to tell me. Okay, now you tell me what how to read this vector vcd. What is it?
Velocity of v with respect to
Velocity of which point? Correct.
v, velocity of with d respect to c,
First of all, you tell me, it is the velocity of point c or velocity of point d?
vd minus vc.
Okay, whatever, but I want to say you, I want to ask you, it is velocity of which point? मैंने जो यहाँ पे लिखा है वो
Velocity
velocity
of
किसका
C
है?
from A.
Velocity of, करेक्ट बोलो.
C.
यस, इट इज वेलोसिटी ऑफ पॉइंट सी. जो पहला पॉइंट है उसका वेलोसिटी है ये, देखो याद रखो इसको. जो हम पॉइंट पहले लिखते हैं उसका वेलोसिटी है, इट इज अ वेलोसिटी ऑफ पॉइंट सी. ना जो दूसरा पॉइंट है वो क्या बताता है? इट इज अ रेफरेंस पॉइंट. ओके, so it is velocity of point C with respect to point D. with respect to point D, इसको ऐसे रीड करते हैं. ठीक है, वेलोसिटी ऑफ C with respect to D. And what will be the name of this vector? अगर आपने इसको ड्रॉ किया कैसे कि ये है वो वेक्टर, it is the vector of any point C with respect to D. Okay, so जब आप इसको, when you write the name of this vector, okay, you will write it opposite way. That is, name of this vector will be small d c. What it indicates, that this vector starts from this point. Which point? D point. This vector will start from D point. So starting point is here. It is the starting point of the vector D. Okay, and ending point is this. So here I will show the small letter C. Okay, as this arrow is pointing towards point C, what it means, that it is the velocity of point C with respect to D. Okay, suppose if I will reverse it like this, suppose here it is D and here it is point C, but I will show the arrow in opposite direction like this. Then what it will represent? It will represent the velocity of point D now, because this arrow is towards point D. So I will write it like this. It is velocity of point D with respect to which point? Point C. Okay, and that's why we say that velocity of C with respect to D is not equal, is not equal to is not equal to velocity of d with respect to c, because directions are opposite. See, and you know that a vector is not only having the magnitude but also the direction. That's why we cannot equate these two, and we show negative sign here like this: velocity of c with respect to d is equal to minus velocity of d with respect to c. I hope you understand how to label the vector, right?
Yes, sir.
Yes or no?
Sir.
लेबल करना है मतलब उसको नेम देना है. Okay, now let us have some exercise. So suppose I will write it like this: say of point p, velocity of point p with respect to q. Okay, tell me what is the name of this vector. बताओ.
Vector Q.
करेक्ट, नेम क्या रहेगा? पहले तो व्हाट इज इट? इट इज वेलोसिटी ऑफ पॉइंट पी का वेलोसिटी है ये विथ रिस्पेक्ट टू पॉइंट क्यू. ठीक है, इसका नाम क्या होगा? जैसे यहाँ पे वेलोसिटी ऑफ पॉइंट ए विथ रिस्पेक्ट टू ओ, ये वेक्टर का नाम क्या है? ये वेक्टर का नाम है ओ ए. वेक्टर को कैसे रीड करते हैं? पहले उसका स्टार्टिंग पॉइंट रीड करते हैं और जहाँ पे वो एंड हो रहा है तब उसको रीड करते हैं. तो स्टार्ट पॉइंट ओ है और एंड पॉइंट ए है, तो उसको रीड कैसे करेंगे आप? ओ ए. ओ ए ओ ए जो वेक्टर है ये क्या है? इट इज अ वेलोसिटी ऑफ पॉइंट ए विद रिस्पेक्ट टू ओ. तो उसी तरह अगर आपको ये वेक्टर को नाम देना है वेलोसिटी ऑफ पी विद रिस्पेक्ट टू क्यू, तो इसका नाम क्या रखोगे आप? व्हाट विल बी द लेबल फॉर इट?
QP.
करेक्ट, बोलो.
QP.
क्यूपी, राइट. जो वेक्टर निकलेगा वेलोसिटी ऑफ पी विद रिस्पेक्ट टू ए, इसका जो नाम आएगा वो ऐसे आएगा क्यू पी. ये वेक्टर क्यू से स्टार्ट होगा, क्यू पॉइंट से, और पी पॉइंट पे एंड होगा. ओके, सिमिलरली वन मोर एग्जांपल. ओके, suppose I write velocity of point r with respect to s. So you tell me what will be the name for this vector?
SR.
S r, correct. So small s, small r. So this vector will start from s point, small point s, or in it, and it will end at small point r. Okay, so this label is very important. That how you label the vector, how you understand the sense or direction of vector. Okay, I hope all of you are comfortable with this. Then I can proceed forward. Should I?
Yes, sir. Yes, sir.
It's very simple. So to summarize it, what we have learned in this slide, first of all, how to label the vector, first thing. Okay, then how to represent a vector with the help of direction and magnitude. So length of the vector will be proportional to its magnitude. Suppose this line I have drawn as 5 centimeters. Suppose if the velocity given was 25 meter per second, and I have chosen the same scale, like 1 meter per second is equal to 1 centimeter, then the line of the vector which I would draw will be equal to 25 centimeter. That is, the length of the vector will be proportional to its magnitude. Okay. So these three things we have learned: magnitude, direction, and label. Label is very important. Magnitude is, you can find with the help of same thing, V equal to R omega. Okay. And direction you can also decide, but label is very important, how you label the vector. Okay. So let us move to the next point. I request all of you to put down your attendance in chat box. Okay. One person is remaining of giving attendance. I think participants 13 are participants, including me. So 12 participants, and in chat box 11 I can see. Since he has just joined and not paying attention, it seems so. Okay, so let us go to this next point: motion of a link. Okay, it is also very important to understand this concept. Okay, now see here, it is one link. Okay, this particular link, I have selected any 2 points on it. So one point is point B and one point is point A, and I have joined them with some line like this. Okay, now let us see the motion of point B with respect to point A. Okay, suppose this link has some angular velocity omega. Okay, uh, now it is in this position like this. After some time it may become like this, because it got some angular velocity. It got some angular velocity omega, because of which it will keep changing its orientation. Okay, now let us consider the motion of B with respect to A. Okay, for example, point B is here at one end and point A is here. Okay, so looking at these two positions, can you say that some sort of motion took place between point A and point B? Yes or no? Yes, you can see. See, it is the uh, say it is the next position, A dash and B dash. So अभी जो सेकंड पोजीशन है लिंक का, उसमें पॉइंट ए जितना मूव हुआ है यहाँ से यहाँ तक हुआ है, ठीक है, उससे कहीं ज्यादा पॉइंट बी मूव हुआ है, राइट? देखो पॉइंट बी ने कितना डिस्टेंस मूव किया है और पॉइंट ए ने कितना डिस्टेंस मूव किया, मीन्स यू कैन से that point B has some additional velocity with respect to point A. With the help of that additional velocity or relative velocity, the B has managed to travel more as compared to the point A, right? Yes or no?
Yes, sir.
Correct. So I will say that velocity of point B has some relative velocity, with respect to point A. Okay. Why I am saying it relative velocity? Because point A is also in motion. Okay, point A is also moving, point B is also moving. That's why I am telling it as the relative velocity of B with respect to point A. So if suppose if I have to draw this vector, I have to draw this vector, I have to label it. I have to give it some name. What will be the name of it? ये जो वेक्टर है इसका नाम क्या रहेगा हमारा? वेलोसिटी ऑफ बी विद रिस्पेक्ट टू ए वेक्टर क्या रहेगा? नाम what will be the name of it? How to label it?
AB, AB,
Yes,
AB,
AB, correct, right. So this vector will be small a b. Means I have to start drawing this vector with respect to point A. Okay, so from point A I will start. So suppose I select, in this particular case I will assume that my point A is somewhere here. Okay, so this vector AB will start from this point. यहाँ से draw करना है हमें. Okay, but we have to decide the direction, that in which direction point B is moving with respect to point A, right? Okay, now you see this particular configuration, that this point B and point A both are on same link, right? Yes or no?
Yes, sir.
Point B and point A are on the same link. So it is not possible at all that point B will move towards point A. Means the distance between them will never change. That is, the movement of point B along the line which is joining point B and point E is not possible. The distance will always remain same because both the points are on the same link, right? Yes or no? Tell me whether point B can move towards point A or away from point A like this. Can point B move away like this from the point A? Move हो सकता है क्या point B और point A? Means can they come closer on this line, line AB? लाइन ए बी पे जो उनका डिस्टेंस है वो कम हो सकता है क्या
नहीं सर,
पॉइंट बी और पॉइंट ए में?
नहीं सर,
बोथ पॉइंट्स आर ऑन द सेम सॉलिड लिंक. Yes or no?
yes sir,
Yes. So it is not possible that point B and point A can come closer to each other or go away from each other. So the motion of B is possible only in one direction. What is that direction? That is perpendicular. Okay, perpendicular to the line which is joining A and B point. So point B will move in this direction, which is shown here. Point B cannot move in this direction. It cannot move even towards A. It will always move perpendicular to the line which is joining point A and point B. Means in this particular direction it will move. Okay. So now you got what is the direction of velocity of point B with respect to A. क्योंकि हमें वेक्टर अगर ड्रॉ करना